All right, so you've really been digging into Geoff Hinton, huh?
Mm.
The brains behind deep learning. It's crazy to think how much his ideas are everywhere now. Like, you know how Netflix seems to know exactly what you want to watch before you do? Yeah, that's just the tip of the iceberg. And who knows, maybe AI is even helping to edit this very deep dive right now. You sent over a whole stack of articles about him, too, which is awesome. And they cover a huge chunk of time, like almost a decade. We've got stuff from way back when he first joined Google to the news about him winning the Nobel Prize just recently.
It's pretty amazing to see how his work has evolved, right?
Yeah.
It just shows you that what seems like a really out there idea one day could be the next big revolution.
For sure. It goes to show that it pays to be curious, I guess. So are you ready to unpack some of these Hintonisms? We've got scaling up, dark knowledge. I mean, some of this stuff sounds like it's straight out of a sci-fi movie.
And yet it's driving some really important real-world stuff. It just goes to show how good Hinton is at taking these big abstract ideas and making them actually useful.
For sure. So let's start with this interview from 2014, right when he joined Google. It's really cool to see what he was thinking at that point in his career.
What I like about this interview is that you can really see his ambition, but he's also got this great sense of humor. He talks about making Google a ton of money with deep learning, but he doesn't say it in a cocky way or anything.
I see what you mean. Like, he knows he's onto something big, but he's not letting it go to his head. But beyond the jokes, it's clear that he's really focused on this idea of scaling up neural networks, which was a pretty radical idea at the time.
Oh, absolutely. Back then, researchers were mostly working with pretty small neural networks because they were limited by how much computing power they had. But Hinton was already talking about training networks with millions or even billions of units. He could see that the real power of deep learning was going to come from going big.
So it's kind of like he was looking at the same puzzle as everyone else, but he realized that he needed to find bigger pieces. What's even more interesting is that he was willing to try things that other people weren't even considering. Like, he even talked about mixing deep learning with other machine learning techniques that most people thought were totally different.
Right. You're talking about how he was interested in using support vector machines or even random forests along with deep learning. That was pretty controversial at the time. Most researchers were really stuck in their ways. But Hinton was willing to see if these different approaches could actually work together.
That's so cool. It reminds me of that saying, if all you have is a hammer, everything looks like a nail. Clearly, Hinton was not afraid to think outside the box. And speaking of expanding horizons, let's talk about one of his most important ideas. Dark knowledge. Even the name just makes you want to know more.
It's a really fascinating concept, even if the name's a little creepy. Basically, Hinton was trying to solve a problem that comes up a lot in AI. Deep neural networks can do some incredible things, but they can also be super complex and use a ton of computing power. And that makes them really hard to use on everyday devices like phones or even things like hearing aids.
That makes sense. So how do you take these really powerful AI models and make them fast and efficient enough to work in the real world?
Well, that's where model compression and dark knowledge come in. Imagine you have this huge, really accurate deep learning model. It's slow, but it always gets the right answer. Hinton's idea was to train a smaller, faster model to copy the bigger one, sort of like an apprentice learning from a master craftsman. That's the idea behind model compression.
Okay, I think I'm following you so far, but where does the whole dark knowledge thing fit into this?
Okay, so instead of just giving the smaller model the same training data as the bigger one, Hinton had a different idea. He thought about using the predictions of the larger model to train the smaller one.
Wait, you mean the predictions. So instead of telling the smaller model, this is a cat, you'd tell it, the big model thinks this is a cat with 90% certainty, but there's also a 2% chance it's a dog and a 1% chance it's a fluffy pillow, and so on.
You got it. And this is where it gets really wild. Hinton realized that those probabilities, especially the ones for things that were unlikely, were full of useful information. It wasn't just about being right or wrong. It was about how the bigger models saw the connections between different things, like a cat, a dog, and a fluffy pillow.
So it's like the smaller model is learning how the big model thinks, not just what it thinks.
That's a great way to put it. It's learning from all the subtle things that the bigger model learned during its training. And that's what dark knowledge is. It's the knowledge that's hidden in those predictions.
Wow, okay, I have to admit, this dark knowledge thing is pretty mind-blowing. It's like teaching a student how to think, not just what to think. No wonder his work was so influential. But before we go too far down that road, let's jump to the part where Hinton wins the Nobel Prize in Physics. Which is kind of a big deal, right? It's not every day that a computer scientist wins a Nobel Prize in physics.
It really goes to show just how much of an impact his work has had.
Mhm.
And not just on AI, but on how we understand intelligence in general, like in our own brains, too.
Hmm.
And the really interesting thing is that the Nobel Prize announcement actually connects Hinton's work to someone who was doing really groundbreaking work with neural networks way back in the day, John Hopfield. Have you heard of Hopfield networks?
I feel like I should know more about them. They have something to do with the way our brains store memories. Like, they were one of the first examples of how artificial neurons could work.
You're exactly right. Hopfield's work back in the 80s was totally groundbreaking. He came up with this idea of a network that you could basically teach to recognize a pattern, like, let's say, a picture of a cat. And then even if you showed it a messed up version of that picture, the network could still figure out that it was a cat.
So it's like the network wasn't just memorizing pixels or something. It had learned what a cat actually is.
Exactly. That was a huge step towards developing AI that could understand the world the way we do. Not just crunching numbers, but actually seeing patterns and making sense of things. But here's the really cool part. Hinton didn't just use Hopfield's work as inspiration. He took those ideas and made them even better.
Okay, so what was Hinton's big breakthrough?
He took this idea of associative memory and combined it with stuff from a totally different field, statistical physics. He ended up developing something called the Boltzmann machine, which is similar to the Hopfield network in that it can also learn to recognize patterns. But the Boltzmann machine was even cooler because it could do something the Hopfield network couldn't. It could create entirely new examples of things based on the patterns it had learned.
Well, hold on. So you're saying that it could not only recognize a cat, but it could actually come up with a picture of a cat it had never even seen before? That's some next level stuff.
Exactly. It's all about understanding what's going on beneath the surface, like the hidden connections in the data. And that's one of the things that the Nobel Committee was recognizing when they gave Hinton the prize. It wasn't just about building better neural networks. It was about how his work changed our whole understanding of how information gets processed, not just in machines, but in our own brains too.
That's amazing. It's like his work is showing us that there are these deep connections between how our brains work and how AI works. And to think it all started with that funny interview we were talking about, where he's joking about making Google a bunch of money.
It really makes you think, sometimes the things that seem like throwaway comments can actually tell you a lot about what someone's really thinking. And speaking of which, remember how he casually mentioned being interested in combining deep learning with other kinds of machine learning?
Oh, yeah, he just kind of slipped that in there, didn't he?
Right. And that little detail actually tells us a lot about how he thinks about AI. He wasn't content with just being really good at one thing. He was always trying to push the limits and find new ways to do things.
It's like that quote, creativity is just connecting things. Hinton wasn't afraid to try new things and borrow ideas from different fields. And you know what? That kind of thinking is super relevant today, especially in the world of AI.
I totally agree. AI is changing so fast, and some of the coolest stuff that's happening is coming from people who are willing to mix and match different approaches, combining things like deep learning with stuff like symbolic reasoning or probabilistic programming.
So like Hinton didn't just create deep learning, he gave everyone the tools to take those ideas and do even more amazing things. You know, it's funny when you think about it. Hinton's whole journey kind of reminds me that the best ideas often come from the most unexpected places. Like when you mix different fields together and suddenly, boom, you've got something totally new. Makes you wonder what other crazy combinations are out there just waiting to be discovered, right?
Oh, for sure. And it's not even just about like the technical stuff. It's about what these new technologies mean for us as humans too. Hinton's work wasn't just about building smarter machines. It was about pushing the limits of what we understand about ourselves.
Totally. And that brings up some big questions too, right? Like the possibilities with AI are mind-blowing, but also kind of scary at the same time. If we're building these super powerful machines, how do we make sure they're used for good? How do we make sure AI benefits everyone, not just a select few?
Those are the questions, right?
Yeah.
And there aren't any easy answers. It's something that we all need to be talking about. Ethicists, philosophers, people who make the rules, and everyday people like us. We all need to figure out how to deal with this stuff.
It's a team effort for sure. And honestly, after going this deep into Geoff Hinton's world, it's clear that we got to start having these conversations like yesterday. We can't just sit around and wait for the future of AI to happen. We've got to be a part of shaping it.
I'm with you 100%.
Yeah.
And I really believe the best way to do that is to be realistic, but also hopeful. We can't ignore the risks of AI, But we also can't forget about the incredible things it could help us achieve. We need to figure out how to make AI work for us, not the other way around.
Well said. It's like we've been given this amazing gift, the ability to create machines that can learn, but now it's up to us to use that gift wisely.
It's a huge responsibility. It takes guts and careful thinking. It's not just about what we can build, but what we should build. What kind of future do we actually want?
And on that note, we've come to the end of our deep dive into Geoff Hinton and the incredible world of deep learning. But before we go, I want to leave you with one last thought. What role will you play in shaping the future of AI? Will you be part of the conversation? Will you fight for ethical and responsible development? Or maybe, just maybe, you'll be the next Geoff Hinton, the one who changes everything we thought we knew. No matter what you choose, remember this. The future of AI isn't set in stone. It's up to all of us to decide what it's going to look like. So let's get out there and build the future we want to see.